So good afternoon everyone. In this video we are going to discuss about the temperature measurements. What are all the instruments which can be used to measure the temperature, those things we are going to discuss over in this particular video. So first, temperature measuring instruments may be classified either according to the range of temperature measurement or according to the nature of change produced in the temperature sensing elements. Okay, so here according to the temperature measurement, change of temperature, the substance causes a variety of effects such as according to the change of physical state, change of chemical state, change of physical dimensions, change of electrical properties, change in radiating ability, the substance, it may causes the variety of effects. Okay, so the next thing we are going to discuss about the difference between the resistant thermometer and thermistor. If we take down the resistant thermometer, so here resistant change in the temperature will shift into the small and positive. Take down the thermistor, here resistance change with temperature shift is relatively large and negative. Okay, so on the resistant thermometer, it provides the linear temperature resistant relation. Here thermistor, it provides a non-linear temperature resistant relation. The resistant thermometer, it provides the practical operating temperature range minus 250 to 1000 degrees centigrade. So the practical operating temperature for thermistor is the minus 100 to 275 degrees centigrade. Okay, so the resistant temperature thermometer, it have more time, it has to be stable and provide the better reproducibility and the low hysteresis. And thermistor, it have no time stable. Okay, so this is about the difference between the resistant thermometer as well as a thermistor. Then comes into the electrical resistance thermometer. The electrical resistant thermometer properties. First one, the material should permit the fabrication in convenient size. That is one thing. Second one, its thermal coefficient of resistivity should be high and constant. And third one, they must be corrosion resistant and should undergo changes with the temperature range. And the last one, provide the reproducible and consistent result. So these are all the properties that resistant thermometer should have. Okay, so then comes into the electrical resistant thermometer one. So here they will be provided the electrical resistant thermometer. So like the end plate is fixed over here, resistance windings they will be provided here, silver core, it will be passing over in the mid of the component, and ceramic insulator made it around the top. Okay, the leads are provided, it will be inserted on the ceramic insulator, and on the outside they are providing some housings over there. So same like here also, one housing, that is cell housing, the resistant winding, it will be placed in the mid, and also the springs they will be provided in the top, and mica insulation. So they will be provided towards surrounding of resistant windings. So even here also which one, it will be provided in the surroundings. Ceramics insulator, they will be provided surroundings of resistant windings. Okay, centrally it is made up of like a core. Okay, leads will be connected over here, same like here also the leads will be connected over somewhere else. Okay, so this is about the drawings of this one, electrical resistance winding. So in the electrical resistant winding, actual resistant temperature relation must be determined experimentally for most metal. The following empirical equation may be used. So here RT is equal to R naught into I into AT plus BT2. So with AT plus BT2, with the help of this equation, the resistance temperature to be determined over here. So here the RT is referred as a resistance temperature. RO is the resistance of reference temperature, and T is the temperature, and A and B are the constants depending upon the material. So it may be depends upon the so many materials, so the constant it may be varies. So usually here we are using the platinum, nickel, copper as in the material, like A and B we are using platinum, nickel, copper, and although we like use the tungsten, silver, iron can also be used for the material like A and B. So this is the electrical resistance thermometer. Next we are going to discuss about the instrument for resistance thermometer like a Seabed arrangement. These things we are going to see now. So instruments for resistance thermometer. So some of the Siemens and cylinders floating potential arrangements are used over here. So here first we are going to see about what is the instrument resistance thermometer. Okay, so actually some type of bridge circuit normally used in the measure resistance change in the thermometer. So normally Wheatstone bridge which can be used to measure the resistance change in the system. Okay, so it leads to appropriate the length are normally required, and any resistance change in them due to any cause affect the measurement. Hence the lead resistance must be as low as possible related to the element resistance. Okay. So there are three methods compensating the lead resistance error are shown here. So in this figure there will be shown as a Siemens 3-lead arrangement and calendar 4-lead arrangement, floating potential arrangements. So here all the instruments they can use for the Wheatstone bridge principle. So what is the Wheatstone principle? They are connected with the 4 resistance. So if any one resistance it will be imbalanced. First initially it will be balanced with all the 4 resistors. Suppose buffer supply give any one resistance, it will be imbalanced. That will be noted down with help of the meter reading. That will be converted as changes in the resistance. Okay. So in the 3 methods, it will be compensating lead resistance errors here. So the arms AD as well as DC each contains same length of this one. So AD and DC. So DC. Okay, so these are all the having like each length will be same and having the identical ambient condition and also identical property and identical properties at ambient conditions. Then the effect it will be introduced by one arm will be cancelled the other arm. Okay, one arm will be cancelled in the other arm. So first we will discuss about this in the Siemens 3-lead arrangement. The simple corrective circuit at balance condition, the central lead carries no current. Central lead carries the no current, and the effect of the resistance, the other 2 leads cancelled out. The other 2 leads it will be cancelled out. The calendar's 4-lead arrangement solves the problem by inserting 2 additional lead wires to adjust the leg and bridge so that the effect of the lead wires on the resistance thermometer cancelled out. Here the 2 lead wires has to be arranged over here. So from that the effect of other 2 lead wires, the resistance thermometer cancelled out over here. Then comes into the floating potential arrangement is the same as in the Siemens construction but with extra lead. So this is the extra lead that provided over here. It may check the equality of the lead resistance. Okay, so the thermometer reading may be taken in the position of shown over there. So followed by additional reading with the two rights and left leads interchanged. Respectively, by averaging these readings, more accurate results may be obtained over here. Usually, null balance bridge used to used, but limited static and slowly changing temperatures, while the deflection bridges is used to rapidly changing the temperature over here. Okay, so to avoiding the to avoiding the resistant thermometer cancelled out, they are used over some more leads introduced over in the calendar 4 lead method or as well as the floating potential arrangement. So here this 2 lead will be connected over here. Here 1 lead is connected over here. So this is about the instrumentation of resistant thermometer. Then comes into the Seabed effect. So in the Seabed effect, there are two different material will be connected over here while joining point. These two different material, the EMF will be exist between the 2 points A and B over here. So which is primarily function the junction temperature. This phenomena is called it as Seabed effect. So once the different material will be going to join together in this point, the EMF it will be exist. Okay, so this effect is called as Seabed effect. Then comes into the next one, Peltier effect. When two metals are connected external circuit in such a way that current drawn, the EMF may be altered slightly owing the phenomena is called Peltier effect. Okay, so then comes into the next Thomson effect. So here the temperature gradients exist along either or both the metals. The junction EMF may undergo additional site alteration. This is called it as Thomson effect. Okay, so hence there are three EMF present in the thermoelectric circuit. One is the Seabed EMF caused by junction of dissimilar materials, Peltier EMF caused by current flow in the circuit, Thomson EMF resulting from temperature gradient of the metals. So that the temperature measurement. So thank you.